Hello, CIS265. Dave Levy here, Professor Dave. Um, so I wanted to do an introduction to CIS265. I'll be co-teaching this with Professor Bogner, and Bogner is going to handle Module 2. I'm going to handle Module 1. When we talk about Module 2 and Module 1, I think that just means like week 1 is me, week 2 is him, week 3 is me. So we're going to be kind of alternating like that. So here we go. Let me switch over to my screen so you can see what's going on there, and then I'll kind of talk you through this module and maybe introduce some concepts to you and coach you along. Also, I kind of want this to be kind of free form. So if you have any suggestions for things you're getting stuck on or videos you'd like me to make, send me an email in Canvas and I'll crank one out. So here we go. Okay, here we go. I haven't prepared this, but let's just talk through what we got here. Let me move that video over there. We're in Canvas here. You're in CIS265, and so I can assume you know how to go to mesacc.edu and click the Canvas link at the top, log in with your MEID. And so what you'll want to do is flip through each of the modules here. So I'm going to click on modules and go through each of these. You'll notice real quick that you'll see these little circles over here, empty circles. These are things that you have to complete for each section. So you'll see these are homework assignments that you have to submit. And when you do submit them, or when you achieve the objective of that assignment, a green check mark shows up there. So that way you can kind of tell which ones you've got left. You'll only see module 1 right now. We'll be unlocking more modules as the class goes on. And I think at some point we'll probably unlock more than one so that you can start working ahead. But for the first couple weeks, we like to keep it pretty simple. All right, so first read the intro, read our welcome letter. To contact us, use Canvas over here. There's a course syllabus that you must view. So let's do that right now. I'm going to click on this, and so go ahead and click on one of these and take a look at it. Okay, so a lot of this stuff is, boilerplate. If you've taken our classes before, you kind of know not a lot has changed in the course syllabus. So go ahead and read through this. I don't want to waste your time on that. That was Cisco web meetings. Let's close that too. So it's both using the camera. Okay, so now let's go back to modules again and see if it worked. Did it work? Yep, there's your green check mark. So now you know you've done that. And look through the assignment schedule, all this stuff. At this time, there's the coronavirus, so I hope everyone is keeping safe and keeping healthy. But no in-class sessions are going to be, for now, at least the next 3 weeks. So it's going to all be online from now until you hear otherwise, basically. That's why we want to be extra accessible. I believe we're going to start setting up a Slack channel, it's called. Slack is a chat, kind of like a chat room. And so you'll be able to hopefully chat with the instructors. And while you're working through your assignments, if you get stuck, you can post in the Slack. And then if we're available, then we'll try to respond. Okay. So here we are in Module 1. Introductions. This is kind of like what we're supposed to do in class. So to introduce myself, okay, I'm Dave Levy. I have 8 apps in the App Store, all written in Swift. But actually that's not true. My first 2 apps were written in Objective-C, and then I transferred one of them to Swift. And I have my first app in Swift UI, which is Apple's new coding language. Maybe we'll get into that. Actually, it's not a new language. It's a new syntax for the Swift programming language. And so I've gone through the cycle of conceptualizing an app and building it and releasing it, several times. So I think that I can help you out. Also, let's see a little bit about myself. I have a wife and a daughter, and in about a month and a half, I should have 2 daughters. And I also have 4 chickens and a couple dogs. And I play Dungeons and Dragons 5th edition. Although I started at basic. All right. My allergies are picking up, so I'm sorry if I'm sniffly or stuffy. This is where we would ask you to introduce yourself and tell us a little bit about yourself, but sadly, we're not in class right now. Okay, read lesson 1, protocols. Now, you know what this means is you go to the book. So what we're talking about is app development in Swift. Let me see if I've got books on here. I do. So I'm opening up books. It's available on your phone, your computer, and this is the one, not the intro one, not this one here. This is for the first class. This is for classes 165 and 265. So whenever it refers to read in the documentation, that's what it means. It means open up the book and turn to chapter 4 and read through protocols. And protocols are a little tricky. So let's see what we got here. Protocol Playground. Now, I actually have a video on protocols, and I'd maybe suggest you watch that. But let me pause right now and see how best to tackle protocols here. Okay, yeah, this is pretty cool. Professor Bogner, I believe, or Apple, someone put together this this protocols download. So if you click on this and download this and extract it, we can talk through this. They're explaining to you what a protocol is. So protocols are kind of, I like them a lot because they force you to adhere to a blueprint of methods and properties. So what that means is, like, while you're creating your app, in this case down here, they've got this thing called a cat. And they're saying let's make a pet protocol property. So if you make a pet protocol, then all things that adhere to the pet protocol will have to have the blueprint for being a pet included. So you can't forget things. That's pretty handy. So let's see, did they actually make the pet protocol yet, or should we make it ourselves? Yeah, it doesn't look like it's made. So let's take a look. So we've got a class here called cat. And let's learn about protocols by giving the cat a protocol called pet. So you just simply start typing protocol and then pet. Protocols are different than a lot of other things in that you, like, if this was a class, you'd say let number of legs of type int, something like that. And protocols are different in that they don't store any properties in them. Yeah, you have to get and set the properties. So you would do something like this first. So what this is saying is there's a thing called a pet, and you got to get the number of legs when you create a cat. Okay, so at least that's how I think of it. Let's see, what else does a pet maybe have? Maybe all pets will have. Well, see, it's interesting because the cat has a name. But you would think that, like, maybe you should move this name up here. So I'm going to do that. I don't know if this is how I intended it to do it, but that's how I'm going to do it. So you move it up there, and then it's going to yell at you because you need to either make a get or a getter and a setter. And the difference between get and set. I have a video on that. I'll link to it in the description because I'm going to blunder through that. But basically, it's a little different there. So you can't have a let. It's going to be able to change. So we're going to change from let to var. So there's this variable called name, and now it's upset down here because you've taken out the name. Well, what we're going to do is what I'm going to do for now is just ignore this warning here. Actually, wait a second. There's a warning. I'm going to turn on my red light. Yep. Warning. That's okay. We'll leave it there for now. So I installed the little backlight. I use that for Halloween. It's pretty sweet. It's like $30. And it lights up like half of the house, so I got 2 of them. Okay, enough about that. Class cat. So to adhere to the pet protocol, we're going to say of type pet. I like to think of the colon as of type. So when I kind of translate it in English to my head. And I'm lazy, so I wait for it to try to help me fill in the gaps here. See, if you wait, then it tries to fill in what the protocol portion is. So I'm going to click fix here. And so see, when I click fix, now it just plunked in everything I need for this cat to be a pet right here. Number of legs and name. And now it's kind of happy again down here, or it should be eventually, because we've got a name returning. And in fact, I don't think... yeah, I might need to look into that. I think maybe, no, that should be fine. Just let it think about it for a while. Okay. So see what we've demonstrated at least now is that we've made this thing called a protocol called a pet, and it has to adhere to these things. Name and number of legs. That's all it for now. You could add more things. In fact, you can add things like functions in here too. So a function called pet might make noise. And it's going to return, let's just say it returns a string to make things easy. Now in protocols, you don't actually, you don't have the curly braces back here. Normally you'd have like, here's where the function is. But in a curly brace, I mean in a protocol, you just say, hey man, there's this thing called a make noise, and it's going to happen when you have a pet. So here's what you can do. You can say, fix that. And see what that does is, here's where you define the function, down here in each thing that adheres to the protocol. So I'm going to return, in this case, I guess a cat goes meow. Cool. So now it's making sure that it's adhering to this protocol. Now Swift has all of its own protocols built in also. Oh, why is this unhappy? So that's really interesting. Well, to make things simple, maybe we can just say that the name is optional. Because it's what it's saying is like, you need to assign a name, dude. So if we do that, you cool with that? If I build it? It's not cool with that. All right, fine. Fine. Let's do this then. We'll just start them off with a name that's like this. A blank name, right? Now are you cool with that? Oh. It's not saying it's got a problem with the name anymore. The name is fine. It's cool with that. What it's saying is we're not initializing all stored properties. So what it's saying is like, hey, how many legs does this thing have? And so what you can do is, let's see, it happens, number of legs happens before name. So put it up here, number of legs, and it's a int. And then here we do this old trick. Number of legs equals number of legs. Okay, now you cool with that? I don't think we have to define the function yet. Yeah. And so now down here, when we declare a cat, anytime we declare a cat, we've got to include, hey, there's this is how many legs. This cat has 4. Maybe this cat had a horrific accident and it has 3 legs. Okay. Pet protocol properties. Yeah, we did that. Pet protocol function, we did that. Class properties are down there. Okay. I see that was, let me undo that because that was to make things easier. So pet protocol properties are up here. The protocol function, by the way, Command X is to cut and copy. So you don't have to Command C, Command V. It's like all built in one. Class properties down here. All right, the code needed to implement the custom string convertible protocol. Ooh, we're getting fancy here. So in addition to being a pet, well, let me demonstrate what this is going to do. First of all, see how we're printing something down here? And when you print a cat, look, it gives you this horrific, like, oh, what the heck is that? That's not very expressive. So what we wanted to do is we want to change it to where you say, where you print the cat, it prints something actually meaningful. So that's what this protocol is. This protocol is not something that I built. It's something that is built in with Swift. So you can adhere to custom string convertible in there. And I wait for it to yell at me. And then I click that and it'll add the protocol stubs. So what that adds is this variable called the description. So the description, now I don't want to have to define the description every time I initialize it. I just want to make this description be a collection of what I've got. So basically, like, it's going to reference the name and the I'm copying it down there. The name, maybe the color, something like that. So here we have a cat by the name of, let's just start with one thing. Just the name. Okay. And let's see if it's cool with that. doesn't like it because, oh, okay, gotcha. Because it's not really defined exactly yet. Stand by. Oops, I was doing that wrong. Yeah, it's like instead of doing it like that, you do it like this. Return. You return the string that you want with this particular protocol. So make some room here. Put that back down there. Make it look nice and pretty. Okay, so you set up a variable of description of type string, and it returns a string with the properties inside of it. So here we have a cat by the name of name. Oops, I was troubleshooting something there. There we go. And let's try it. So now, if we run it now, hopefully we get this to work. Here we have a cat by the name of Percy. Here we have a cat by the name of Momo. So you can be very specific about what your print statements are doing. That's just what custom string convertible does. Now it's kind of, the cool thing about like protocols is you can use them in structures, classes, and even enums, although I don't see any use case for that. But so if you have, like, instead of a class, you've got a structure called a dog, and you can make it of type pet. And just setting up the structure like that with no properties in there, it's still cool with that. It's like it just tries to put in what you need. So return woof, and the number of legs is kind of undefined at first there. It might force you to put some default values in there. Let's see what happens. So let's make a dog down here just to kind of see what happens here. Cat 345. Oh, I see. So there's more cats down here that I was unaware of. Fix. Oops, that one's got 44 legs. That's cool. And let's throw a dog in here too. Let dog 1 equal dog. And then start and stop that thing. Say it's got 4 legs and his name is Grover. Okay. So it's cool because you can use the protocol stubs in structs or classes, and they can be the same protocol used for both. Fancy, huh? So that's kind of an example of protocols. There's equatable protocol and there's the comparable protocol also. Yeah, okay, let me go through those two because those are actually really important ones. Equatable is, here, let me just go through them. And wait, let me just double check that I've got all my errors gone. Yeah, all my errors are gone. I better turn off the red light. No longer an emergency. There we go. Equatable is like checking if things are equal. So all right. So equatable is checking if things are equal, and we could check like if 2 dogs are equal or if 2 cats are equal. Let's see here. Oops, that was something I was actually going to prepare for you here. I had to do an edit there because I started down the wrong path. I started making sure to see if our dogs are equal. But then I started thinking about it and thought, no, I think I should put equitable or equatable in the pet protocol. So it applies to dogs or cats. Both dogs, both cats have equatable kind of thing. So I'm going to make sure that pets are equatable or equitable. I'm going to say equatable because it makes more sense to me. And now a cat doesn't conform to it, and the dog does. That's what's interesting is for some reason it's cool with like trying to check if 2 dogs are equal, but not cool if checking if 2 cats are equal. So what we're going to do is, so first let's identify how are we going to check to see if the 2 dogs are, or the 2 pets are equal, I mean. Now we could check their name and their number of legs, but there's a lot of different dogs named Spot, and there's a good chance that 2 Spots will have 4 legs, and then you're not really checking equality properly. So what I would do is I'd make this new variable and call it unique identifier, UUID, and make it a string. And then I don't think you can't assign, so I can't just generate a unique identifier right here because this is a protocol. You can't store any properties in a protocol. But I can say hey man, every pet's supposed to have a unique identifier and be and also every pet should conform to oh my gosh. You should be able to check to see if the two dogs are equal. Okay, so now the problem is that there's this function that it's not randomly filling in. Well, maybe it will. Okay, it's putting the UID in there, and I'm going to fix this one. And okay, cool. It put the function in here. If you don't remember this function, then look it up on the internet. So search for equitable on the internet. And what this is, it's overriding this function that is pretty much changing what the equals does. What equal means, usually it's just like are these two properties equal? And you just compare them. In this case, we want to be very specific about checking equality for a cat. We want to make sure that the left-hand cat, this is LHS, RHS. I like how Apple tells you never to abbreviate things, and then it does it right here. Left-hand side and the right-hand side. So when you're comparing the two cats, the one on the left, how does it compare to the one on the right? So here's how we're going to do that. We're going to return true if it's equal, it's the same cat if the unique identifiers are the same. And then I'll show you how when we generate a new cat to generate a new unique identifier with it. Okay, let's do that first. So here's that code I copied. So there's this thing called UUID, it's a unique identifier, and there's a function to generate a string. So now every time we create a new dog, it's going to create this unique string for a dog. I'm going to copy that down here and put it here. This is how I would do it in a real legit app. And I like this function stuff. I'm going to put that up here too. But instead of it being for a cat, it's going to be for a dog. And what that's doing is saying the left dog and the right dog. We check to see, return true if... So basically, I'll just type it out. I mean, there's a fancy, shorter way to do it, but let's do it this way because it'll read better. If the left-handed side dog's unique identifier is equal to the right-handed side dog's unique identifier, then return true. Everything else is baloney. Okay, there's a fancier way to do it, but I don't know. I like when it's legible. If left-handed and right-handed is equal. Okay, so I'm going to do this again, copy this, throw it down here, and good to go. Now we should be able to check to see if the left and right cats are equal. How would we do that? So if cat 1 is equal to cat 1, print, hey man, that's cat 1 again. A fan. Okay, so let's just run the function up to this point and see. Hey man, that's cat 1 again. Yep, there it is. And let's also just double check. I'm just going to put in here cat1.uuid just to show you kind of what its unique identifier is going to look like. See, it's this garbled, this nonsense over here. So now if we check to see if cat1 and cat2 are the same, let's just double check that and run it again. It should not execute this code. It does not. It gives us an error though. That's cool. Wonder why. Unterminated something or another. I think that might have been my fault. I think it might have printed this out, or I don't know what. Okay, I'm stopping here, but I think it's working. Yeah, I just unpaused to let you know that it is working. See, it didn't print it out. Okay. All right, let's see. We did equatable. Comparable is very similar. It's just to see which is greater than or less than. So you'd write a similar kind of bit of code to check to see if something is greater than or less than. Like you might, I don't know, compare how many legs a dog has to make sure it's greater or less than the other one, or just compare the greater than or less than name. Like, so you put things in alphabetical order. something like that. So let me, I'll pause, I'll set that up, and I'll show you to save you some time. Okay, and just to demonstrate the, I don't know, a concept, I'm gonna say that every pet has a quality, like maybe it's you know, high quality, low quality. So the higher the quality, the I don't know, the better it is. That sounds terrible, but we're just gonna do that for this demonstration. So I'm setting up a property for dogs called quality and cats called quality, and then we're gonna say down here, just to demonstrate, cat 1's quality is equal to 8, and cat 2's quality is equal to 7. No, let's make it terrible. Let's make it a 2. It's like garbage cat. Okay, and pause. Okay, this is kind of interesting. So I went to put comparable in there, and it turns out that comparable is kind of built into equatable. So it's redundant. So we don't need this because equatable has a property or protocol called comparable already built into it. So you could use this comparable by itself, or you could use equatable, and then you get them both for free. So now I'm saying pets are equatable. You can, is one equal to the other? Yeah, well, that it's also built in, is one greater than the other. And I built in this thing called quality, so the quality of the dog and the quality of the cat. And so you'll see, here's where we check to see if they're equatable. Is one equal to the other? Now you can just in the same way do a function called static function less than. So instead of like declaring your function, you know, this or that, you're saying less than. And it's overriding the less than symbol. So then anytime you check to see if something is less than or greater than from now on, if it's a dog, less than or greater than is now referring to the quality of the dog. So if less than quality is less than, or actually I'm going to say not less than or equal to, just less than the right-handed quality, then return true, otherwise return false. Otherwise, when you compare dogs to dogs, you say less than, is this dog less than the other one? It might not know what you're talking about. So it's going to want me to do kind of the same kind of thing for the cats. And you could have a very complicated function in here. If the quality is less than, and the weight is, and the age is, or, you know, you could do all kinds of checks to see which is less than, greater than the other. And the same thing goes for the greater than symbol, the less than or equal to, all that stuff. So let's see here. Now we're talking about cats here, not dogs. And that's it. Okay, so if you have any questions about this, it gets a little bit interesting, you know, comparable, the equatable thing. I guess we have to test it down here, right? Is if dog, oh, there's the cats there. Cat 1, because I've already given them the quality. I didn't make it required that we define their quality, so who knows what will happen if we try to compare it if they don't exist. Cat 2 would probably say no. Quality. If cat 1 quality is less than cat 2 quality. The other thing about this is, I think once you define 1, like the less than symbol, it infers the greater than is the opposite. So I don't think you have to define them both. I think you just define 1, the less than, and possibly, yeah, I think less than or less than equal to. Anyhow, it kind of, if it's not working for you, then add some more comparable stuff. But I think you just have to define 1 less than, and it kind of infers all the other ones through some sorcery. Okay, print. Oh, we like cat 1 better. Okay, and then I'll do it else here. Else, we like cat 2 better. Okay, let's run it through here. Oh no, what did I do? Let me try it again. I think oh, it's mad at me. Red alert, folks. Okay, where's it mad? I returned without, so it's like this cat thing. It wants me to say the quality for the cat inside of here. So I'll throw quality in there. It's going to yell at me, surprised where it is. whatever. Self dot quality equals quality. All right, command. You can't do B. I usually do command B to build and run, but assigning to property self. Did I spell it wrong? Quality. Yeah, I spelled it wrong. Quality. Quality. Okay. How are we doing now? Let's see. It's missing arguments. So it's now he wants me to fix all these cats. This one's a 3. Oops. This one's a 5. I don't know what I did there. Something probably broke something else. This one's 76. Sure, why not? We didn't give any restraints to... Might be amazing. Okay, there's what I broke. All right, there's probably more cats down here too that are mad. I'm just going to comment this out for now so we can get on with our lesson here. And go. Oh, and go. It's thinking. Oh, good. We like cat 2 better. Okay, let's make sure that's true. Cat 2's quality is 2. Uh-oh. Cat 1's quality is 8. Uh-oh. I think my logic might be messed up here. So let's go ahead and look at our comparable thing. Less than. L, less than. Yeah. If left-hand side is less than the right-hand side, then return true. Maybe I got that backwards. Let's go ahead and flip these around and run it again. I don't want to think too hard on that, but they still like cat 2 better. If cat 1 quality is less than cat 2 quality. Oh wait, cat 1 is less than cat 2 quality. Oh, my logic here is messed up. If cat 1 is less than cat 2, we like cat 2. Oh gosh. I need more caffeine, folks. Okay. So let's do that. And then I think I had this right up here. Okay. Oops. So let's think about this again. Quality. Left is less than right. Return true. Left is less than. Okay. If cat 1 is less than cat 2, forget cat 1. We like cat 2 better. Okay. Come on. Let's do this. Oh my god, I have it backwards again. No, I got it right. Oh my god, I had to take a break. Okay, let's do this a little different. Let's just return this. See what happens. There's a lot of different ways to skin a cat. Okay. So if cat is less than another cat, then we're just going to compare the qualities. Okay. So if cat 1's quality is less than cat 2's quality, cat 2 better. Or else cat 1 is better. Now let's take a look. Cat 1 should be better, right? It's got a quality of 8. Cat 1 is better. Now what if cat 1 is a quality of 1? Cat 2 is better. Now we'd have to write some extra stuff for cat. They're equal. Cat 1 is better, it's saying. So how would we do that? Yep. Well, actually, this is kind of problematic, right? Because we're using equals equals up here to check to see if it's the exact same cat. I mean, so we're kind of messing ourselves up here. Because if we check to see if they're the same, then they're not the same cat. We can just to see if they're greater or equal than at this point. I suppose we could do, no, see, it's and when you return greater or equal than, or less than, when you return, if it's less than or not, it's either going to be less than or it's not less than. So we've got ourselves in a bit of a pickle. We either want this to be checking the quality of the cat or the identity of the cat. So in this case, you might choose one or the other, but not do both, you know. Okay, I can turn the red alert off. I think we've gotten through protocols safely. Thank you for your time. I'm going to pause now and take a look ahead at what else is in your Canvas course here. See what we can get through, because there's a lot of, the governing board is having a meeting today about COVID-19. And there's a lot of stuff in this class, and I don't want to bore you or drone on and on and on. But it looks like if we went over protocols now, let's see, there's, oh good, there's all these videos you can watch too. Well, hang on. Well, you read anatomy, app anatomy life cycle, and maybe we'll go through this keynote, and then we'll talk a little bit about MVC and your assignment. But let's take a break and continue in a moment.